we have two parabolas. In first equation, we have x squared. It means our parabola is symmetric about y-axis. And in the second equation, we have y squared. It means our parabola is symmetric about x-axis. To find this area between these two curves, first we need to find intersection points. So let me calculate from the first equation y. So let me copy this. We have x squared minus 4y is equal 0. So I will move negative 4y to the right side. So we have x squared is equal 4y. Next I will divide both sides by 4. So we have that y is equal 1 over 4 x squared. So now we will substitute y in the second equation by this form. So let me copy this equation first. We have y squared is equal 4x. So we have that 1 over 4 x squared. We have to take to second power is equal 4x. So it will be 1 over 16 x to fourth power is equal 4x. Next I will multiply both sides by 16. So we will have x to fourth power is equal 4 times 16 is 64x. Next I will move the right side to the left. So we have x to fourth power minus 64x equals 0. We can factorize x. So it will be x cubed minus 64 is equals. So we have to find the x when the left side will be 0, when x will be 0, or we have x cubed minus 64 is equal 0. So this is equal x cubed is equal 64. So x is equal cube root of 64. This is equal 4. So we have x equals 0 and x equals 4. So now we have to find the y coordinate. For x equals 0, we can put to this equation y is equal 1 over 4x squared. So for x equals 0, we will have that y is equal 0, because 0 to second power times 1 over 4 is still 0. And when we put now that x is equal 4, we will have 1 over 4 times 4 to second power is 16. 1 over 4 times 16 is 4. We have intersection points. So now we will draw y axis and x axis. We need to find the unit. Let's choose 1, negative 1. We have points 0, 0 and 4, 4. 2, 3, 4, 2, 3, 4. So approximately the second intersection point is here. Now we have to draw two curves. First, we have x squared minus 4y equals 0. So we found that y from this equation is y is equal 1 over 4x squared. So let's choose. We have these 2 points which our curve must pass, and let's choose 2 more. For x equals 1, we will have that y is equal 1 over 4. So it's approximately here. And for negative 1, the value will be 1 over 4 too. Parabola y equals 1 over 4x squared is symmetric about y-axis. So when we have point 4, we have to have point -4 in the second quadrant. So our parabola looks like this. This is our first curve. This is y equals 1/4x squared. Let me put also this equation. This is x squared minus 4y equals 0. Next, we have to find our second curve is y squared equals 4x. So this parabola is symmetric about x-axis. So let's find from this equation x. So x is equal 1/4 y squared. I divide both sides by 4. So now we have these 2 points because we have intersection points. So we need 2 more points to draw this graph. Now let's put for y 1. So we will have for y equals 1 will be 1/4 times 1 is 1/4. This is approximately here. We have 1 point. And for -1 will be 1/4, the same value of x. Like I said, our parabola is symmetric about this x-axis. And we have to pass this point and this. So this is approximately something like this. So we got area between these 2 curves. Let me shade this. This is our area which we have to find. We have this area between interval from 0 to 4 when we are looking from the y-axis. So let me write. We have area. We will have integral from 0 to 4, and when we are looking from y-axis, we have to first plug the right function. The right function is this part. The whole parabola has equation x squared minus 4y. So the x will be equal plus minus square root of 4y. This part will have positive sign. So we will put square root of 4y and we have to subtract the left side is this part, the left side. And again, because y squared is equal 4x, so x from this equation will be equal 1/4 y squared. So we have to plug 1/4 y squared. And we have integral with respect to y. So this is equal. We have square root of 4y, so this is equal. Let me rewrite this. We have integral from 0 to 4 of 2 square root of y we have, so will be y to 1/2 power minus, let me copy 1/4 y squared dy. So this is equal. Integral of 2y to power 1/2 is 2 times y to power 3/2 over 3/2 minus, and we have 1/4. Integral of y squared is y cubed over 3. We have definite integral, so we have to plug integration limits from 0 to 4. We have first expression we can rewrite. It will be 2 times 2 over 3 y to power 3 over 2 minus 1 over 12 y cube. Integration limits from 0 to 4 we have. First we will plug upper limit. So we have 4 over 3 times 4 to power 3 over 2 minus 1 over 12, and we have 4 to third power minus the lower limit is 0, so when we put 0 for y will be 0 times whatever we have here will be 0, and when we plug 0 for y cube will be 0, so we don't have to plug the lower limit. So this is equal 4 over 3. We have 4 to power 3 over 2. So square root of 4 is 2. 2 to third power is 8. Minus we have 1 over 12 times. And we can rewrite this that this is 16 times 4. So this is equal. We can reduce by 4, 12 will be 3, and 4 we can cancel. So we have 4 times 8 is 32 over 3 minus 16 over 3. So this is equal 16 over 3. So our area between these two curves is equal 5 and 1/3 square units. This is my solution.